Welcome to solverfy.
This is chapter 27, problem number 16. We are given a proton that is moving along a circular trajectory from a point A to B. And we know the initial velocity. It's 1.41 times 10 to the power 6 meters per second. This circular motion is due to the magnetic force acting on the proton. So, as you know, the direction has to be along the centripetal direction, so that with the initial velocity, the initial speed, the particle would go along the circular trajectory. So this is the direction of f sub b. And we are asked to calculate the magnitude and the direction of the magnetic field. So just simply from right-hand rule, we can say that the direction of B has to be out of the board or the screen, right? For a positive charge. And in order to determine the magnitude of it, as you know, your f sub b is qvb, since there's 90-degree angle between the velocity vector and the force. I'm not adding sine 90 here, which is 1. This has to be equal to, from Newton's second law, mv squared over r when you have a circular motion. So from here, if we want to go to the magnitude of the magnetic field, then we divide both sides by qv. These are going to cancel out. You're going to have the magnetic field to be, these are going to cancel, mv over qr. So here, by plugging in numbers, the mass for a proton is 9.11 times 10 to the power of negative 31. Velocity is 1.41 times 10 to the power of 6 over the charge is 1.6 times 10 to the power of negative 19 times the radius, which is also given to us. The diameter is given. We're going to take the half and then convert the centimeters into meters. So we're going to have 0.05 meters. So if you do the calculation, then we're going to have 1.6 times 10 to the power of negative 4 Tesla for the magnitude of the magnetic field, and also the direction is out of the board. Now we are asked in part B, let's put it here. In part B, we're asked to calculate the time that it takes for this proton to go from point A to B. As you know, time equals distance divided by the speed. Our distance is the semicircle, so it's half of 2 pi r, which means it's pi r over the speed. You might say, oh, okay, the direction of the speed is changing. However, the magnitude of the speed is not changing. That's why, and you can just use it here. Then if you do the calculation, 3.14, which is the value for pi, times 5 over 1.41 times 10 to the power 6, you will find that it takes 1.11 times 10 to the power of negative 7 seconds for this proton to go from point A to B.